Hello, friends. Grab your coffee, grab your cookie, and today, please keep both far away from any wet scrubber exhaust or chemical mixing area because we are talking about one of the quiet heroes of dust collection, polypropylene filter media, also known as PP. If polyester is the workhorse and Nomex is the firefighter, polypropylene is the chemical shield. I am Michael Klepik, and for 15 years I have been designing dust collectors for chemical plants, fertilizer production, wastewater facilities, and industrial processes where moisture destroys ordinary filter media. Today I want to explain why polypropylene exists and where it absolutely dominates. What polypropylene filter media really is. Polypropylene filter media is a synthetic needle felt fabric made from PP fibers specifically designed for chemically aggressive environments. Technically speaking, first, maximum continuous operating temperature is 170 degrees Fahrenheit. Second, the fiber itself is hydrophobic and does not absorb moisture. Third, it has excellent resistance to most acids and alkalis. Fourth, it maintains strength in wet environments. Fifth, it is chemically stable in environments where polyester fails. Polypropylene is not about heat, it is about survival in chemistry. Where polypropylene filter bags are used, I typically use polypropylene in applications like, first, chemical processing plants, second, fertilizer and phosphate production, third, acid and alkaline powder handling, fourth, battery material processing, fifth, wastewater treatment facilities, sixth, wet process exhaust systems, seventh, food and pharmaceutical environments with washdown procedures. If moisture or chemistry is present, polypropylene immediately goes to the top of my list. Why polypropylene performs so well in wet and chemical environments? Polypropylene has several key advantages. First, it does not absorb water, so it does not swell. Second, it resists chemical attack from acids and alkalis. Third, it maintains tensile strength when wet. Fourth, it does not hydrolyze like polyester. Fifth, it performs reliably in condensing air streams. This makes polypropylene ideal for applications where filters get wet, intentionally or accidentally. Temperature and environmental limits. Of course, polypropylene has limits. First, maximum continuous temperature is 170 degrees Fahrenheit. Second, it is not suitable for hot exhaust streams. Third, it softens at elevated temperatures. Fourth, it should not be exposed to strong oxidizing agents. Fifth, it is not designed for abrasive, high-temperature mineral dusts. If the air is hot, polypropylene is the wrong choice. If the air is wet, polypropylene is often the best choice. Behavior of polypropylene in airflow and filtration. Inside a dust collector, first, polypropylene handles wet and sticky dust better than most fabrics. Second, it forms a dust cake more slowly due to its smooth fibers. Third, airflow remains stable in humid conditions. Fourth, pulse jet cleaning works well at moderate pressures. Fifth, the fabric maintains shape and strength even after repeated wet cycles. It is predictable, stable, and forgiving in harsh environments. Which torch air systems use polypropylene media? Torch Air commonly installs polypropylene media in Blizzard chemical duty pulse jet Baghouse used in fertilizer, chemical, and acid handling operations. Blizzard wet air baghouse designed for condensing air streams and moisture-rich exhaust. FOEHN cartridge systems with PP media used where chemical resistance is more important than temperature. Custom chemical exhaust collectors built specifically for corrosive industrial environments. Polypropylene is a specialist, but a very important one. OSHA and application compliance polypropylene filter media helps meet, first, OSHA particulate exposure limits in chemical environments. Second, acid and alkaline dust handling guidelines. Third, food and pharmaceutical hygiene requirements when approved grades are used. Fourth, environmental regulations for corrosive particulate. Fifth, general industrial ventilation rules in wet environments. The key requirement, temperature must always remain within polypropylene limits. Dust collector system design considerations. When I design a dust collection system around polypropylene media, I focus on moisture and chemistry control. First, differential pressure sensors designed to account for wet dust behavior. Second, condensate drainage systems inside ducts and hoppers. Third, automatic hopper discharge to prevent wet dust buildup. Fourth, corrosion-resistant ductwork and housings. Fifth, lower pulse jet pressure to protect soft fibers. Sixth, sloped hoppers to prevent sticky dust accumulation. Seventh, access doors and washdown friendly design for maintenance. This turns polypropylene into a long-lasting, reliable filtration solution. Polypropylene filter media is the right answer when moisture and chemicals destroy other fabrics. With excellent resistance to acids and alkalis, strong performance in wet environments, and a maximum continuous operating temperature of 170 degrees Fahrenheit, PP filter media fills a critical role in modern dust collection. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, when chemistry attacks, polypropylene fights back. See you in the next video.